Hi, my name's Nathan Glover. I'm a senior DevOps consultant from Mechanical Rock, and today I'm going to talk to you about how I fed my cats with the Alexa Gadgets Toolkit. Let's start by going over the agenda. What is an Alexa Gadget will be what we cover first. Then we're going to jump into why you might use the Alexa Gadget Toolkit. What can the Alexa Gadgets or Alexa Gadgets do? We're going to talk about an actual practical example of how you might use the Alexa Gadget Toolkit. And then we're going to finalize this presentation by building an Alexa Gadget cat feeder. So let's start by talking about what is an Alexa Gadget. Well, Alexa Gadgets can be seriously anything. They're basically a companion device for the Alexa, and they connect over Bluetooth, and they're able to interact with your environment. So why would you use the Alexa Gadgets Toolkit? Well, I'd like to talk through this by giving you an example of what, well, I guess the state of IoT looks like. So the IoT device market is anticipated to reach about $1.1 trillion by 2026. That's over 152,200 IoT devices per minute by 2025, which is hard to fathom. And in that, there's over 100 million Alexa-enabled devices, and that stat was taken from the start of 2019. On those Alexa-enabled devices, there are 90,000 plus available Alexa skills, and that stat was taken from April 2019. So you can imagine in 2020, there's probably a lot more. Now this quote stood out to me. Fewer than 20% of risk professionals can identify the majority of their organization's IoT devices. That's things like keeping track of their fleets, what devices are deployed where, and it's kind of scary to think about. And 76% of risk professionals think IoT leaves them at risk for cyber attacks. So people are obviously acknowledging the fact that these ad hoc devices could potentially be causing problems when they're not audited. So let's have a look at a typical smart home device. So this is maybe something that you find in your home at the moment. It could be from a dishwasher or a microwave. You'll typically have the device, and it might talk back over AWS IoT Core, for example. It could be connected to a Lambda backend and DynamoDB table. So in this example, you might talk to your Amazon Echo. You might ask it, can you please check the fridge for milk? And that skill goes and hits a Lambda, and that Lambda writes some data or pulls some data from Dynamo and talks over IoT Core to your device. Now this is good and all, but there's a few problems, and I call this the land of potential mistakes. I guess there's a lot of opportunities here for companies who might not necessarily be technically savvy to make mistakes in this area, because this is arguably requires a little bit of technical understanding to code up the environment of IoT Core, Lambda, and DynamoDB connected to your device. Now, it's your responsibility to keep your customers safe, so you obviously want to make the right decision to check that you're using a tech stack that you're able to maintain and ensure that your customers are safe. So with that in mind, this is where I think Alexa Gadgets falls into this quite well. This is the architecture for an Alexa Gadget. You have a device, it connects over Bluetooth to Amazon Echo, and then from there, it can connect to your backend Lambda. This simplifies the whole process because you remove effectively the entire backend. Now, this is great for both hobbyists and product manufacturers because they can focus on what they do, which is building great devices for their customers. They don't need to worry about the communication stream through Alexa. That's all handled for you by gadgets. There's also the same functionality footprint, like same functionality with less footprint is I guess the way I describe it. And you could say this is arguably more secure because there's less services you need to manage yourself. So what can Alexa Gadgets do? Well, let's look at some examples. We'll start with looking at a timer and alarm. There's a clock you can buy that syncs up to your Alexa and displays things like timers if you have any active. It can give you LEDs around the ring of the light, around the ring of the clock that basically tells you how long is left on your timer. It'll even sync the time to the internet, which is something that you'd think a clock would be able to do, but this allows it to do it. One of my favorite ones, though, is tempo sync. So this is where anything that comes through the Alexa device can sync to a gadget. In this case, it's a dancing bear. So this bear twerks to the sound of music coming out of your Alexa. This is probably my favorite device. The final one is speech. Whenever Alexa makes or sounds or speaks, speech data comes through the Alexa gadget and it can react to that. So there's a lot of examples of singing fish that will talk whenever Alexa talks. So now let's go through how you might use the Alexa Gadget Toolkit. And for that, we're going to go through a demo. And what you're going to need for that demo is, or in my case, what I'm using is a Raspberry Pi with Bluetooth 4.2 plus and an Ethernet connection. Though in theory, any device should work, provided you've got those two prerequisites. Now there's official support for Raspberry Pis and embedded C devices, but like I said, this should technically work on any device that has Bluetooth 4.2 and an Ethernet connection and a C method of running C code or Python. You're also going to need an Amazon developer account and an Echo device that is compatible with Alexa gadgets. Now here's a list of the supported devices. I'm not going to go through them all specifically, but in my case I'm using a Echo Spot, which supports both classic Bluetooth and Bluetooth Low Energy. So now we're going to go through a demo of the creation of an Alexa video service product. Now let's go through and create a new Alexa AVS product. You can do this by navigating to the AVS product page under the developer portal and then clicking Add New Product. From here we need to give our product a name. In this case, we're going to call it DevOps Star Cat Feeder. Next, we need to give it a product ID. In this case, we'll call it DevOps Star _cat _feeder _AWS. This product ID must be unique within your account. Next, we need to select what type of product we're going to use. In this case, we're going to select Alexa Gadget. If you were building another type of Alexa skill or product, you might select one of the top ones. Next, a product category must be selected. We're going to go with novelty device because that best suits what our thing is. Now, you provide a brief product description. We'll go with Smart Home Cat Feeder that will refill food bowls on request. Next, we upload an image that matches our product. I'll go ahead and put in a picture of a cat. Then you need to select whether or not you're going to distribute this product commercially. Again, in our case, that's a no. The final question is whether or not this is a children's product or is otherwise directed specifically at children younger than 13-year-olds. We're going to go with no for this. Finally, accept the terms and conditions and hit finish. Congratulations, your gadget is being created. Next, navigate back to the product page and select the new product we created. You'll have an Amazon ID and an Alexa Gadget secret. You'll need to keep these handy for a later step. You can also preview some of the settings and fields that we set in the previous steps. So let's talk about the devices that I'm using. So I'm using the Echo Spot and the Raspberry Pi Zero W. Now we're going to go through the setup process for an Alexa gadget, making use of these tools. In this demo, we're going to go through setting up the Alexa Gadget's Raspberry Pi samples on your Raspberry Pi. To do that, get into your Raspberry Pi and apt install a few dependencies such as Git, Python 3 pip, and Python 3 dbus. These are required in order to run the samples project and the Gadget SDK. Once that's done, let's head over to the Alexa Gadget's samples repository under the Alexa GitHub organization and clone this repository onto our Raspberry Pi. You'll find the project is actually quite large, so you'll need to take a few minutes to wait for it to clone. Next, we're going to change directory into the Alexa Gadget's Raspberry Pi sample directory And we're going to run the launch configuration with the setup flag. This will go through the initial setup of our Alexa gadget. We need to provide the credentials that we were given in the previous step, so we can go back over to the product page and pull out the Amazon ID and gadget secret. You need to punch these into the configuration steps as they come through. So I've got my gadget ID in there now. And next we're going to grab our gadget secret. Now obviously after this demo I'm going to revoke these because I don't want anyone else to be able to use my gadget ID. So remember, this is a secret, so don't share it with the world. The next step will take quite a long time. It goes through and installs all the dependencies that it needs to basically run the Gadget SDK. That includes like the entire SDK and the entire Bluetooth stack, which is quite large. And then finally, once that's done, you'll need to select whether or not using Bluetooth Low Energy or just Bluetooth. In my case, it's BLE, so I type BLE. And we get a success. Wonderful. Finally, let's jump into one of the samples, in this case, the notification samples. There are a bunch of other examples you can check out too under the examples project. But in this notification.ini file, you can see that that has actually set us up our Amazon ID and secrets. Let's talk about Amazon Alexa Gadget Directives. So these are the APIs, so to speak, that you can tap into from your Alexa gadget that comes out of the Alexa device when you open up conversation with it. So there's a few different examples here. There's alerts, so that's things like timers, alarms, the Alexa Discovery, which is probably not really something you interact with, but that's information about the device when it comes online, the actual Alexa device when it connects. Then we've got music data. That's for things like the dancing bear, speech data, that's for things like the talking and singing fish, the state listener, which allows you to pick up things like when you open up conversation with Alexa and you say that keyword, it'll present that information in the state listener. And then there's notifications. That sort of just informs the user of new content that's available from the Alexa domain or other enabled Alexa skills. So let's talk through a sample directive here. So this is data that's coming off the Alexa gadget and is available through the Raspberry Pi. So what you see here is the output of those logs. So here you've got this concept of a namespace. So that's where we've got the Alexa gadget, alexa.gadget.state listener. That namespace is specific for Alexa gadget, so that's alexa.gadget. You can also have custom namespaces, which we will talk about soon. And then you've got your payload data. So this is things like the wake word and any other payload like the speech data that comes through under a directive. And so now we're going to go through a demo of the sample application or the Alexa Gadget notification directive, and we'll give you an example of what that looks like. Now let's go through one of the more fleshed out examples that is provided for you, and that is the kitchen sink example. It can be found in the source examples kitchen sink folder, and within that you're going to get two files, kitchensink.ini and kitchensink.py. That's everything you need to run a gadget project. So let's open up kitchensink.py and have a look what's actually in here. Now you'll find a default class that inherits the Alexa gadget, then a bunch of different definitions that basically handle the directives for all the different types of data you can get back from the Alexa device. So let's go ahead and open up the INI file now and have a look at the gadget capabilities. Now all of those directives you saw before are capabilities. They're callbacks that come from the Alexa device when you have them enabled inside this gadget capability field. So we've got things like the state listener, alerts, notifications, music data, and our speech data too. You need to define all of these in their versions in order to be able to use them. Now let's back all the way up to the top and run one of these examples. To do this, you just need to sudo python3 launch.py example kitchen sink, which references the kitchen sink folder. Now let's go over to our Alexa device and configure the Bluetooth on the device to pair with our Raspberry Pi. To do that, we go into Bluetooth settings and find our gadget, A57, which is the one that was displayed to us in the console before. We should see the gadget connect to our Raspberry Pi. It might take a little bit. Once it's connected, you should see some indication in the console that your device and its MAC address is connected. You'll also see a bunch of information spew out onto the console, which directives that the code is picking up and spitting out. Alexa, set a timer for 1 minute.
1 minute, starting now.
So we've set our timer, and you can actually see that information comes through, including the speech information of Alexa saying back 1 minute starting now. We can also see that a timer has been set. And here is our speech data. Now let's jump over to our Alexa device as the timer goes off and see what happens on the console. Next, we're going to talk about the Amazon Alexa Gadget custom interfaces. So these are these custom namespaces that I was describing before. So let's say you want more than the normal capabilities. You want to be able to program your own custom intents around a custom gadget that you've designed. Well, that's where custom gadget interfaces come to the rescue. Now, there's a few rules around how you can name your namespaces. I've got an example up here, but you need to make sure they start with custom dot and then a phrase, all common letters, uppercase or lowercase. In this case, I've got my cool interface.yay, where yay could be a function that gets called, but my cool interface is like the top level example of that namespace. So you can see on the right there, we've got alexa.gadget.statelistener, alarms, notifications, and then Alexa Gadget speech data and music data. Those are the standard interfaces. And then we've got our custom capabilities, which are the ones that have custom.color cycler gadget as an example on the right there. So now we're actually going to go through the process of building our Alexa Gadget cat feeder. Hooray! This is the most exciting part, obviously. So let's go over the idea that we want to build out. So here's my cat. Her name's Lila. She constantly needs feeding. Every time I check her food bowl, it's always empty. It never has enough food in it. But I've only got an Echo device and a Raspberry Pi. So how can I do that? Well, we're going to build the cat feeder that's always going to be around and connected. So I think it's going to be a perfect idea for a gadget. So how does it work? Well, the Alexa skill handles voice control. We're also going to have a bunch of Alexa code that we're going to deploy with the Ask CLI. We're going to have a Bluetooth connection between our Raspberry Pi and our Echo, and our gadget code, which is going to run and basically open a servo, open and close, that feeds our cat. Now, all the code for this is actually open source too. So if you want to build your own Alexa Gadget cat feeder, you can reach it at github.com/t04glovin/Alexa Gadget cat feeder. Now, to start with, in order to use this code, I'm going to want you to clone this down. So I'm just going to use git clone on the repo. And as you can see, there are two parts to this repository. There's the deployed Alexa skill, which is in the skill folder. And then there's the actual gadget code, which is those two files, the Alexa Gadget catfeeder.ini and pi. So now let's go through a demo of setting up the gadget code on our Raspberry Pi. We should now be good to clone the Alexa Gadget cat feeder source code that I've provided for you guys to use. You're going to want to copy the clone link and then go over to the Raspberry Pi folder into source examples and then clone this GitHub repository in there. This should leave you with a folder called Alexa-Gadget-Cat-Feeder in the examples folder. Let's go ahead and open up the INI file from Kitchen Sink and copy in the gadget settings at the top. So our Amazon ID and Gadget secret, because we're going to need those to put into the Alexa Gadget cat feeder example. So open up the INI file for the Alexa Gadget cat feeder and replace those Gadget Amazon IDs with the fields that we copied from the other. Notice that we've got a custom Gadget intent here of version 1 that we're going to be using, which is called cat feeder gadget. So let's save and back out. Now that we've got the code set up on our Raspberry Pi, we'll go through our final demo where we're going to actually deploy the Alexa skill code to Alexa. Next, we're going to deploy our Alexa Gadget skill. Now to do that, you're going to want to open up the Alexa Gadget cat feeder in an ID of some kind. I'm using VS Code in this example. Now you're going to want to delete that existing .ask folder because that's the one that I use and it has my information from my accounts. You're not going to want to need that, so just remove that. Next, you're going to go to the Alexa Ask CLI GitHub repository and find a link here to install the Ask CLI globally in your Node.js. This process can take some time. Next, we're going to grab the ask configure, which is what we use to configure the CLI. When we run this, we're going to select the default profile because we've already set that up with our Amazon credentials. However, if you do not have an AWS account or do not have AWS credentials, you'll need those and set up in order to do this. Next, you'll get a prompt on the web page that will allow your Alexa CLI to be accessible from the terminal. You'll then be prompted on whether or not you want it to generate an IAM account for you. Just say no in this case. Finally, just run ask deploy, which will go through the process of pushing a Lambda up and linking the skill. This process can take some time, so be patient. Once deployed, if you navigate to the developer console, under Alexa Ask, you should see your skill appear there. If we click on it, we can get more information about it. Some of this information is like the intents that get called and the utterances required to trigger an intent. If you go into interfaces, you can also get information on what APIs are enabled. In this case, we've got the custom interface controller enabled, which is what you need for Alexa gadgets. You can also go into the skill.json file and define the custom interface as part of the JSON definition and rerun the deployment if you don't want to go through the UI and tick that box yourself. Now, there's quite a few components. So let's have a look at the overall hierarchy of all the code that gets run, which piece of code runs where. So this is the full overview, and don't worry, we're going to break it down slowly so you get a good idea of what's going on. Let's start with the top. Let's talk about the launch intent and then that custom cat feeder init. So we've got two components. We've got the first part, which is our launch intent. Now, here's the code on the right. Basically, that file, all it handles is whenever you open the skills, so when you say Alexa open cat feeder, it's going to be triggered, it's going to be triggering that launch intent, and it's going to be sending this custom directive through to the Alexa service, and which in turn gets sent down to your Raspberry Pi. So the Raspberry Pi captures that custom intent, that custom.catfeedergadget.intent, .init I should say, and all it's going to do here is basically reset the feeder. So that function there on the right, we've got on custom cat feeder gadget underscore init. All it is a directive, and our custom code there is just to reset the feeder. So that's just getting the feeder back to a state that's known, closing the hatch, preparing food, everything that we need to begin feeding the cat. Now, there are a few options here. So when you ask the gadget to open up, it'll say, would you like to feed the cat? And we can respond back with either yes or no. So first we're going to go through the no feed intent. So that's when the user says no or nah or not really. And so let's go through each of those. So no feed intent gets captured very similar to the init intent. You'll find that a lot of the code when you go through this repo is really similar. All it is changing a few words to do a few different things. So when we say no feed, it also sends a custom response to the Raspberry Pi. And all that's going to do is pretty similar to the init, which is to clean up. And clean up just resets the feeder as well. So it gets everything back to start and we're good to go. But let's say you said yes, and this is where the real logic comes into play. So we have two intents here, and we've also got the custom cat feeder gadget. So say you say yes to feeding the cat, we start to do something a little bit special where we add a event directive. So we say, cool, you want to feed the cat. Now we set up a timer for 10 seconds. That's where you can see the session attributes token with 1,000 there. We say that we want to report this status. So say that within 10 seconds nothing happens. We report that you didn't report a feed taken place. So this is basically telling the Alexa Gadget or the Raspberry Pi, in 10 seconds, if I haven't heard back from you, I'm going to tell the user that a feeding didn't take place. And we fire that off. Now on our Raspberry Pi, we capture that custom intent. So on custom cat feeder gadget feed cat, we basically run some code to open up the feeder. Then we do something really cool, which is we send a status back to Alexa saying that we fed the cat. So that's self.openFeeder. All that does is just open the feeder. That's all the logic that's really involved here. And that's just changing the PWM. I won't go into too much detail, but it changes the pulse width modulation, duty cycle in order to open and close the cat feeder. And I'll show you a demo of that in a sec. But yeah, we send that custom intent or event that says the feed is true, and that goes back to the Alexa device within 10 seconds indicating that the feed has happened. And that's that report feeder intent. And all this is doing is basically sending back to Alexa, the cat has been fed, meow. So the cloud skill just says, hey, the cat's been fed. And I'm going to show you a video of that shortly. So let's go through the final demo of our working gadget, the most exciting part of this presentation, I think. So the conclusion of this presentation is, I want to say, go give Alexa gadgets a try today, because I think they make things a lot easier to work with. They make your Alexa ecosystem a lot easier to work with. And if you've got it gives you the opportunity to develop interesting ideas for your smart home appliances or hobbyist projects without needing to have too much cloud experience. It also gives the customer a unified experience too, because when they get your product out of the box, if they have an Alexa device, they just turn it on, sync it to Bluetooth, and they're done. That product is automatically linked up. There's no having to log in with any boxes, no having to put passwords in. I would arguably say that it's more secure as well, because all the connectivity happens to Alexa. So you're completely managing that, or Amazon is completely managing that for you. There's that shared responsibility model where you acknowledge the fact that Amazon is probably a lot better at doing this than you are. And like I said, it also bakes in that device enrolling, so you don't need to handle that for the customer. Now, thank you for listening to my presentation. Again, my name is Nathan Glover. You can hit me up on Twitter at Nathan Glover AWS. Senior Dev Consultant for Mechanical Rock. Feel free to ask me any questions, and thank you so much.